Good morning. Oh, proud. Sorry, I did like 20 handouts and I ran out. So everything is online, so you can actually pull it off from here. We're giving you links. In fact, if you go to the...
You need to say it from this area.
If you go to the tiny URL that was just posted, you can actually follow on with all of the links and everything else, because we're going to let you actually follow along with it. So go on to the next one. So this presentation talks about some of the work that was done as part of a CPATH grant. Do people know what CPATH is by any chance? There was an NSF program that looked at computational thinking and different ways of looking at computer science. What was very interesting about the project that we did was I was feeling a little bit whatever, and decided I was going to challenge the status quo for NSF. And so everyone was talking about computational thinking, and everyone was talking about doing it in English and doing it in all these others, but it was all computer science. And I said, well, computer science doesn't own computational thinking. The computational thinking occurs in IT as well, and so therefore what I said that we were going to do was look at computational thinking in IT. And we actually got funded. I was really surprised. So we've had a phenomenal time working in 5 states across the country, in Massachusetts, Virginia, Indiana, Oklahoma, and California, and looked at creating scenarios that could be used in introductory IT classes to help students gain computational thinking attributes. The other thing that we did was created a rubric, and we'll talk a little bit about that. So if you want to go to the next one. So basically what we did, as I said, was really looked at computational thinking as an exercise. And so if you look at I gave you a rubric that we had developed, and this was done in conjunction with industry. And so what we did was Jeanette Wing, who is kind of the mother of computational thinking, had talked about the fact that it's all about algorithmic thinking and recursion and all this type of stuff. And we kept saying, but those aren't the common terms that are used in industry today. So we said, let's try and redo this in the way that industry talks about this, because they don't go in and say, oh, I'm going to go use an algorithm today. They really go in and say, I'm going to create a procedure that's going to do this, and yes, I may use some algorithms along the way or some other types of things. So what we did was, and you see here, is created a rubric that looks at computational thinking. And then what we did was created some scenarios that allowed us to be able to test students' computational thinking capabilities against the outcomes that are on this rubric. So if you want to go to the next slide. So actually, most of it. So the other thing is that what's also very important about computational thinking is computational thinking is not something that is done by just rote presentations and rote memorization of different activities. It's really having students get involved in it to really think about what they're doing, how they're doing it. And so we created, again, these scenarios to allow students to have to do things a little bit differently. Now, the thing that's very important about scenarios is that you can still have the same student learning outcomes that you would have had by having them go through the different processes, but you've done it in a way that allows them to own the process and to have them do it a little bit more critically. So for example, I'll give a very quick example. We teach mobile app development using App Inventor, for example. And so one of the things that we've done is, instead of sitting here going, okay, here's App Inventor, here's how you do this, you come here, you click here, you do this, you do that, we actually have a community-based organization come in, and we tell the students, you are going to have to develop a mobile app for this community-based organization. And so the community-based organization talks about themselves. They have to come up with some ideas around it, and then they have to create some prototypes. Well, guess what? The students get extremely engaged in developing that computer app and that mobile app because of the fact that they now have a client that they're now doing the work for. And the thing is that they actually learn more by doing that as opposed to having to learn how to point and click through it. So it takes a little bit more time at the onset to try to develop it, but it actually takes it actually takes less time in the whole outcome of it because the students become much more engaged and you're not having to push them along. So I think that it's really important to kind of understand how some of these different types of things work. So what we're going to try and do here is try to help you think about how you can do this and you can transform your own work here. So, do you want to go here or do you want, because I've already gone through this.
Yeah, I guess.
Or did you want to do the YouTube?
No, first, but I want to just back up 1 second.
Okay.
How many of you have a flash drive of some sort with you, a USB? I encourage you to download the PowerPoint presentation that we're going to go over, because that way you'll have it to take with. There's some links that you can do, and Pierre has set this up so you can do that on the machines that you're on right now. But we want you to be able to actually use this when you go back to your university or college and implement it. And the whole purpose of today's 2 sessions is to get you to a point where you'll be able to create your own scenario for computational thinking. And the goal then is for you to, as it says here, to be able to not only see how it works, because we've given 5 workshops in Indiana where we've had high school mostly and some middle school teachers involved in the presentations and workshops. And within the 2-day workshop itself, they've been able to generate one self-contained, if you will, scenario that their students are able to use. And they did this, again, in only 2 days. So very impressive in terms of being able to use, as Deborah said, the template that we've created through our NSF grant. And now that's available to you, and anybody else who happens to get on our links can make use of that template so that you don't have to go through the whole, time-involved process of what we went through initially to develop this. And as Deborah said, it's really the matter of being able to use the rubric and to say, how can we measure what's been done in the classroom, where before we really didn't have a good way to do that. Here?
And it's going to be on MPICT website.
I would like to say that the tiny URL is going to remain there. It's on my personal website, so it's going to stay there, so you can download it anytime you want. Yeah, you can put it on Google Drive too. And I want to say that I was very lucky to be asked to participate in this grant. And I was not somebody who was living in it from the beginning, and I really not only enjoyed the experience, but also found how important it was to change the way we think.
Yeah, he was actually quite fun because he's like, I can't do this. It's like, yes, you can. So he was one of our big critics. What a motor.
So we are sharing the research with you, and we've been doing this throughout the last year, really, as part of our NSF grant. Our background, as Deborah mentioned, has been able us to make sure that students are not, like you unfortunately, looking and listening to a talking head up here, but instead being able to interact and to think on your own, because computational thinking is critical thinking using technology. And that's what we've encompassed through this process that we've created through these different scenarios. So there are a couple of neat YouTubes that I want you to look at, because they're short, maybe 4 minutes or less, and they give you a flavor of why we're doing this and what it's all about. So hopefully the audio will come through as well, and we'll see in just a moment. So again, problem-solving process, that's what we're dealing with. If it's a complex problem, if you're a programmer, you're an analyst, it's got a huge project, what do we do? we break it down into smaller units, right? Something that's more feasible for us and perhaps our team members to deal with, so that we get the thing done in a timely fashion. Just like John mentioned this morning at the keynote, being able to have teamwork, to have experiential learning, all these things are put together, and we do that within the scenarios that are built because it's team projects that the students are working on. We don't give them the answer, nor do we tell them how to go about it. We simply give them references and resources that they can use, the students, in order to come up with their own solution, which, kind of like philosophy, unfortunately I'll mention that, right? It's like whatever you want it to be, if you can justify it, oh well, that's what the answer is, right? Well, in a way, we're looking for a specific solution, but not telling them how to do it. Now, there should be some audio on this. Let me pause it for a moment. This looks like it should be there.
Yes, so I don't know if it was muted for this. That's a good question.
So what James said before about possible having some glitches with technology, right?
And I was going to say, it's not only faculty that have a little bit of a difficulty in trying to teach in this way. Students oftentimes have a very hard time learning this way at the very beginning. It's very interesting because many times we have been told that, you know, no, just get us the answers, you know, just tell us what we're supposed to do and we'll do it. And we keep saying, no, 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 you've really got to be able to figure this out, because, as you heard this morning, and I'm sure you keep hearing all the time, being able to think critically is going to be very important for student success. And so what has been fascinating about this project is students would cite it at the very beginning. And in fact, the first semester they do it is often the lowest rated instructor rating ever. And after they actually go back to a lecture time, they come in and say, oh my gosh, get me out of this, I can't stand this anymore, because they've all of a sudden gotten to the point where they realize that even though it was more work, and they had to learn differently, they actually like it better. So it's one of those that once you get them there, they can't return, and so that's also very rewarding. So just a heads up that it's not just a faculty thing, it's a student thing as well. So you can have
how is it differentiated from home-based learning project?
correct, I can talk a little bit about that.
Right. It's somewhat similar to that. I'm coming up with Plan B, by the way.
Similarities to it. You got it?
Yeah, we can just plug this guy in instead. Little hitter, man.
You got it here, huh?
I can bring it up on this and everybody will see it.
Should we actually have one do it and just show it on the screen?
We can do it that way and just turn it up on one.
Chuck,
Pardon?
why don't you go back to the video and just have him just start it? And start
That's right. That's probably the way to go.
Yeah.
Thank you.
Plug this back in.
Sorry.
So if we can coordinate 3, 2, 1, 0, we'll start this.
Okay, can you start back over again?
That's what should be that, man.
Projector is a little bit less.
Let's begin with that. No, we were doing the easy one first.
Nothing yet.
No, I mean,
Let me just do it on this one because I have this.
no, it's just a projector. So you can do
Okay.
There's no projector. Nope. Yeah, I'm seeing on that. Well, as we said, we have all the URLs.
It's just on now. It's warming up.
Okay.
It's off.
So I should put the question. Okay. Is it on now?
It was, but now it's off.
Oh, John, we have some problem in room 1103 with the projector again. Yeah. Okay.
It was on a moment ago.
Is that on anymore?
No.
Are you should.
Doesn't look like it. The light's not on. This should be on.
Yes. So I said, if I'm not patient, tell me I'm going to press once more, and then I'm not going to touch it.
Well, fortunately, you all have it on your own machines, right?
Right.
So what is your running?
Yeah.
Yeah.
Do it on your machine, yeah.
So,
You know,
got that on this machine now.
is it
Not on that one. It's not on this. No.
No, I was just trying to get it down to where we were.
Right, you get that.
Oh, it's only music?
No, it should be. Yeah, there's no words, but the video.
It's all it is music.
Okay.
The music with this one doesn't have audio.
But Jeanette Williams does, right? Jeanette Williams does have it. Yeah, we will.
Yeah. So let me when this is on, and then I will not touch it anymore.
On that third slide that shows what exactly is computational thinking, the last link on there is the one from Jeanette Wing. That's like an hour plus. We're not going to go over that at all. But in your spare time, if you'd like to see more about how she, there we go, how she involves computational thinking and brings it up, it will show. So the next slide is the one that talks about the differences between project-based learning and scenario-based learning. That's what the question was. And you'll see from Pierre, is it possible? I don't know how to switch between.
Here we go. There we go.
Okay, great. So the difference between scenario-based learning and project-based learning, there's some similarities, but the differences essentially are that in scenario-based learning, we don't give the solution to the students. Instead, we give them the problem, we give them references and resources, and let them look up the solution that they think would be the best way to present the solution to the problem itself. Also, there is, as I mentioned before, kind of like in philosophy, there is no one standard right answer. It's how you justify it. So, and I'll give you some examples in just a moment of how I think that would work with SBL, and scenario-based learning through computational thinking. We up in the front of the room, I'm not talking heads, we're simply facilitators. And as Deborah mentioned, and Pierre, it's kind of like a rough thing for us to get used to because we like to be in charge, we like to take control, that's why we're teachers, my wife tells me, right? But in fact, what we want to do is be able to give the ability of the students to look up the answers. And even though they find that very frustrating, as Deborah mentioned in the beginning, they do like it after they find out that they are in control themselves, which is even better, really. Now, because it's team-based, they want to, again, share the load, so to speak, with the different team members. Otherwise, it does become problematic because one person is not necessarily going to be able to do everything. And again, just like in cultural diversity, we want to get everybody's perspective. So it's not just me that knows the right answer, but it's listening to other people in the team and coming up with a solution that kind of melds everybody's ideas together to come up with a better solution.
So a follow-up question on that, then the scenario-based learning, or even problem-based learning. Is there a situation when you would present something like this for the students to work on more individually? Does it always have to be group-based?
So what we often do, so I'll give you an example with the mobile application. We actually have a combination between the two. So the students are responsible for coming up with a proposal for a mobile app by themselves. Everybody must do an individual proposal. However, then they choose one of the three, so those are then voted on, and the top three are brought forward to create a prototype. And then they team up with one of those three in order to develop the actual prototype. So there's a combination of the two, oftentimes. Different ones have different types of either teamwork or individual work, and so when you look at the scenarios that were developed within the CPATH grant, you have a listing of, I think, 11 of them here, and some of them are individual, some of them are team-based, and there's all sorts of different ones that you can have access to. And so it allows students are able to do it in different ways, and you can develop the classroom to make it whichever way you feel is appropriate for the type of concept you're trying to teach.
And I want to say that some of these scenarios can be taught in like 3 weeks, 4 weeks. Some of them can take like a whole semester, correct?
Some of them can be a few days.
Yeah.
One of the critical differences between PBL and SBL is the fact that it could be a subject matter that you're not familiar with, or you're an expert in maybe programming but not security or something of that nature. So the biggest change here is you don't have to be the expert in the particular scenario that your students are going to be working on. That's why we have the outside expert who's going to be the subject matter expert. So the SME comes from industry and business. It's just like our kids. They listen to us, but they don't always hear us, right? If it's some other kid or some other adult, yeah, there's probably a better chance of them understanding and hearing what we're saying. So we bring in an industry expert. They talk about the problem that we've identified for the students. The students then have the opportunity to ask them questions because they're not going to know enough on the surface to be able to know how to solve the problem. They need to get more results of information from the subject matter expert. And then they can put together, and you'll see in our template how that's going to work in terms of being able to have answers to questions that will lead the students in the teams to be able to interact and look up references and resources to get a better handle on what process needs to take place and how it works. Yes?
Students taking this class already have background with design or whatever, mobile app development.
Repeat the question.
Okay, the question is, do the students taking this scenario, do they have a background in whatever the scenario is? If it's security and assurance, if it's database, if it's programming, if it's web-based, answers, not necessarily. We set up most of these as first semester or first year students, freshmen, but it can definitely work in subsequent classes as well, where they do have a background in it, and that, you know, just reinforces the process.
So,
Yes.
so to that question, we in Boston set up a course called IT Problem Solving, because our industry partners all said that it's about the problem solving, it's not about the gadgets and, you know, how to use them and all that type of stuff. So we set up a course. They go through about 5 of the different scenarios, 5 or 6 of the scenarios through the course of that class. And which this isn't about that class. So if you want more information about it, I'm happy to give it to you. But they literally, and these are first semester freshmen. They do it at Bunker Hill Community College. They do it at UMass Boston. They do it in high schools. You know, we've run this course in a variety of different situations. And these students come in knowing very little about, you know, that different topic area. So we take them through the mobile app development, we take them through a green IT type of thing, we take them through the security, we actually do an ethical hacking type of piece. So there's a lot of different things that they're exposed to. So the answer is no. And what we do is really teach them how to learn. Yes. Absolutely.
Are they supposed to come up with somewhat as a prototype and not necessarily a working prototype? That's my, is that a final product or is this a prototype?
So they do, in this course, in this scenario right here, it's an introductory course, it is a prototype. In a mobile app development program, they will do probably a full app development. But this is really to get freshman students understanding what IT is about. Because oftentimes students come in and they have no clue what computing and IT is about. They think of it basically as someone coming in and doing desktop support and not, you know, spreading desktop support by any means, but IT is much more than just desktop support. And so it gives them an idea of the types of problems that they're going to be solving as part of an IT program. So they get into security, they get into database, they get into you know, some of the various security issues, they get into mobile app development. It's a bunch of different things to give them a flavor of the types of opportunities that are available to them.
Okay. Both John and Jay mentioned this morning at their keynotes that it's better, and of course I think we all realize this, to have our students have some real life experience, not just book stuff, not just labs that we work on. Well, that's what scenario-based learning is all about. We bring in an industry expert, we have a problem that's identified, they get students' input from the subject matter expert, and then as Deborah mentioned, we could very well have this a live project that when it's done, the client, if you will, is satisfied, hopefully, with the results that the students have put together. Now, there might be 24 students in the class, 3 students per project, 8 groups altogether, right? 8 times 3 is still 24 according to my math, right? So out of those 24 students, the 8 groups, they're going to come up with the same end result, but it could be different, right? And we let the industry SME and hopefully their boss's boss or whomever come in and have the students make their presentation to them, and they get to choose the one that they feel best satisfies the requirements that have been outlined. So it is real world in that regard as well. I have some of these systems that I want you to take a quick look at, but again, it's kind of like awkward from the perspective that, you know, I'm not able to bring it up totally for you to, no, we can click on it, but I want to grab the one that I want to take. Open? No, not yet.
Go to the slides.
Yes.
The one that says CSTA. Let's see, this one. That's one. This one. So this is the, under Computer Science Teaching Association, this is the one that I want you to take a quick look at, because it does identify again, what computational thinking is. There's also an ISTA, which is another one that we'll bring up just for you to view, and hopefully on your own you can take a more in-depth look at some of these resources. But some of these things Deborah and I have already talked about in terms of what is computational thinking, how does it marry what Jeanette Ring has identified and how we are teaching it so that we have critical thinking using technology. And
And so what you're getting in some of these are a lot of links to a lot of different other examples of what you want to do.
And I want to go back to, pardon me, as I mentioned before, it doesn't have to be information technology itself or computer science, quote unquote. As Deborah said, we've kind of broken that glass ceiling and say, you know, what we do is different than just computer science. And in our scenarios, when we teach the workshop to high school and middle school teachers, of course there's some difference between what a middle school, maybe 6th grader or 5th grader might learn versus a high school senior. And this is an example. And again, on the left side, you'll see the rubric and the template that we use. And this is what one of the high school teachers, this is the Hammond Academy of Science and Technology in Indiana, has put together. One of the faculty members has said, okay, here's the welcome. And again, you can click on yours if this is hard for you in the back to see. You can take a look on your own monitor to see what it is. But it tells the students some information. And in this case it says, there's good and bad news. We've gone back in time and now we don't know how to get back to the current year itself. So we need to melt into the group that we're in, which is in the Middle Ages, and we need to find out how we're supposed to interact with people in that age. So it's a history lesson, right? We also have teachers who have come up with economics, with math, with different scenarios based on their discipline itself, right? Not just IT or IS stuff. So here it says they need to be able to, and you can scroll down. So here's task 1, to identify what the role is of each member of the team. And they assign different projects to different people in the team. Down here you'll see under subpages, requirements, resources, and debrief. The requirements are going to specifically identify what it is that they're supposed to do. And I kind of want to go through this, you know, relatively quickly because we have not that much time. But hopefully I'll whet your appetite with what Deborah and I are talking about with Pierre, so that you'll come back for the afternoon session and you can literally use the blank template to create something yourself for one of your classes. You may not get done with it because we don't have 2 days. We only have 2 40-minute periods. But you'll have a beginning sense of how to go about the process. The resources, if you click on any one of these, will identify information about how it's supposed to work with you at that point in time as one of these types of, I don't want to say class, but that's what they would be back in the Middle Ages, right? To say, if you're a lord or if you're one of the other people within that generation, how do you interact with each other? How do you interact? What is your role essentially? So these different sites are what was made available to those students. We didn't tell the student how to act. We didn't tell the student what questions or how to talk to people. We said, you find out. Go to these references. Go to these resources. And then draw your own conclusions so that they are, in fact, figuring out how they should act within that particular frame. So let's go back one more to the previous one.
Don't go back home, maybe. Good.
Under, yeah. So if we go,
you want to go back to
the debrief, because We teach a lot of experiential learning courses at Purdue University Calumet, which is where I'm from. And one of the roles that we have for students at that point is to say, what did they learn? Reflection, is that right? That's a good term to use in education, right? Reflect on what you've done, how you've learned, what you can learn from that, and how might be to adjust and do something differently next time you have something similar come up. So the debrief is essentially having the students come up with what they learned in that situation. And they're going to be reporting on that. So they're going to come up as a team, in front of the class. So a little bit of, as John mentioned this morning, communication skills, right? Being able to verbally communicate, write down in terms of written communication for a final product, but being able to interact with their peers. And at the end of this semester, they're going to also present this to professionals, to the CEO, to the supervisor, whomever is their supervisor of this client site that they're doing work for. So they need to learn those communication skills, and they practice them in the classroom. As Pierre mentioned, it could be that they're going to have a 3-week project, or it could be an 8-week project. Some of our faculty across the 5 states have done things in 3 weeks, 4 weeks, 8 weeks. So it depends on, A, what kind of, as the lady in the back mentioned earlier, what kind of background do they have, right? Do we need to give them more time to get up to speed with what they need to know so they can do this? So maybe the first 8 weeks of the 16-week semester, they're getting up to speed with doing things that will prepare them so when they go through the scenario, they can do it and get it done in a proper manner.
And it also depends on whether you want mastery of something or whether you want an introduction to something. Because a lot of, in the introductory courses, you're trying to introduce it as opposed to achieve mastery. So you'll see that the length of scenario depends on that as well.
So the sound is working?
Try video.
We can try the YouTube and see if that works. Yeah, just.
Yeah, but they've already watched it.
I know, but just to see if it works.
Oh.
Just to see if it works.
Just click on. Nope, still nothing.
I think something's missing. Let me take a look at that video now. That's hard.
I think we use it for...
It should be working.
Is this supposed to be? Is this supposed to be?
Correct.
Whatever.
Okay, we'll try to fix it for the...
Yeah, we're moving on.
Yeah.
Because we have like 8 weeks.
So, as I mentioned, in our case, we have a lot of experiential learning course requirements for students that graduate with our bachelor's degree from Purdue Calumet. They have to have at least 2 courses using either industry or some other, perhaps working with a professor, coming up with research, developing a publishable paper in a journal, or presenting at a conference. And that experience is the kind of thing that John talked about this morning, to make sure that the students are not just book smart, but also experience smart, so they can get that chicken and the egg out of the way.
How do you do student evaluation?
Student evaluations, part of that is through what Deborah handed out, the rubric. Let's see if I can.
Students actually have to reflect on what they achieved through that. So the rubric was actually transformed into a questionnaire where students have to say, this is exactly what I did, how I did it, what I achieved from it. So for example,
this rubric is not the full rubric that I have.
So in other words, it says something about so for example here that was something, I identified the steps required to solve a problem. Here are the steps that I went through in order to solve this problem. So they actually have to sit there and identify what steps they went through to show that they've actually had to go through the process. So there's a reflective type of piece that they go through, and that's what they're actually graded on.
You do that as a team or...
No, individually.
And what they do in team projects, they actually rate the team members. And not only do they have to rate their team members, they actually have to talk about the contributions they made as a team member. Because that's one of the things that we were told by industry, is we don't want to know that they just participated in the group. We want to know what they did as to add value to that group. So we decided that we would also have the students reflect on what they contributed, as opposed to what their role is and their contributions were to that group. Yes.
Did you peer evaluation?
Absolutely.
The reason that I found just trying small things for my class, basic class, is the students who do not do well on the normal objective test do much better on these types of things than the students who we normally think of as smart.
Correct. And vice versa. So they're not the ones who get everything really quickly, don't want to take the time to go through a lot of what this is. So yes.
Yeah, I'm going to follow up on that because I have yet to see a job description called professional test taker.
Right.
Yeah.
I also, with my students, I actually have a couple of team members who list the contributions of their team members to see if there's jobs. Because sometimes the student doesn't really maybe do it.
Well, and it's also interesting because in a lot of the groups that I've run in classrooms, they could actually fire team members. And so that was always a very interesting aspect of it because I said, well, if they're not contributing, you can fire them. And then all of a sudden they have to come up with their own team of all the fired people. And so that's a real rude awakening for them.
So this is the full-blown rubric that we've come up with,
right,
where we identify whether or not the students have actually achieved a particular level of knowledge based on the different criteria that we're thinking about grading them on, if you will. This is in addition to what Deborah mentioned about team grading. Okay, there's another one which I'll show you that we have from the people that have gone through our workshop, having them be able to have their student workers in a team rate each other, and that's another survey that they complete.
So what's very interesting is this is the actual things that they have to reflect on, and then it's compared against those three areas. So they can actually look at what they should be achieving as they move forward. So they know that if they're supposed to look at design decisions, they know whether they've accomplished it by looking over here. And then if they haven't, they see, oh, well, I didn't do all of this, then I'm more in this. And so students get to a point very quickly where they all of a sudden say, oh, I've got to actually get this over here in order to be able to get to where I want to be in this course.
And this is another significant advantage of using the method that we have with the template, because now there's a way the students know in advance what they're going to be quote-unquote graded on. And it's just like you or I preparing for some certification. If we don't know what the criteria is, it's harder than heck to be able to be successful in it. So we allow the students to know this up front. Okay? Question in the back. Warren, did you have a question?
Oh, yes. Thanks, Jeff. I wanted to say that I really like the view that correct me if I'm wrong, that means I'm trying to get a better grasp on this computational thinking versus IT problem solving. And the profound statement that this gentleman had mentioned about students who normally don't test well do better on this type of stuff. I assume he's talking about SBL, PBL. It seems like it's backwards. I mean, this is all the critical thinking, problem-solving, computational thinking attributes on the rubric here. If people normally don't, in general, do well on an exam, yet they have the ability to solve problems in critical thinking. Usually, it seems like that entire teaching methodology needs to be change.
Well, I think to summarize basically what you said is, I think that what is happening is we're thinking much more of the content itself as opposed to the processes that students go through in order to be accomplished in it. And so the more that we work with students on the processes as opposed to just the content learning, the better off they're going to be, and the better off they're going to be as they get into a job or anything else, because that's what's going to count. The reality is, and I think the keynotes this morning emphasized that all of this changes over time, and students have to be constant learners. And if we equip them with these capabilities, they are going to be better learners as we go forward.
I want to say a couple of comments along with this question of assessment, because I have been in the classroom. For me, this was the biggest challenge, and I think the rubric really helped me, but ultimately I was able to apply verbatim. It was good help, and I did some of the work with the students, some of the things that were recommended. This is the biggest challenge for us, because we've simplified our grading system to the ultimate, with the bullet point set, and then you really have to feel a big change in readability. And as students who are doing that, I have them doing some self-assessment and mutual assessment itself. But this is the challenge for those of us who have not done this for a while. So we have to really, I really this responsibility. And the comment that the students who do well in the test, the traditional test, don't do as well there, and some other students really shine in this kind of test.
We've kind of whet your appetite with how it works, and if you're able to come back to the afternoon session after lunch, we'll let you actually do this, and we'll walk around and help you through the process of going through the template, which is also on the website, which if you have a USB or whatever downloaded to your own machine is fine, because it's really exciting. It's like, it makes teaching different, but different in a better way, because the students, as Deborah said, when they come back after having a quote-unquote normal class, as opposed to SBL class, they say, wow, I want to do more of it. And it's exciting. It's exciting to be part of something different in a better way. Yes?
Are you doing any kind of process where you're, rather than using scenarios for the teachers to understand the value of this type of approach?
Yes.
Sometimes, if you don't have an educational background and try doing stuff like this, you feel like you're in the mold.
So the question comes, do you do this for teachers? So professional development, that at least that we run as part of this project, is all done in a scenario type of fashion. So they come in, they do. You've gotten a lot more kind of talking at you than you would ever see in one of the workshops that you attended with us, because we're trying to give you a lot of an overview of what it is. And then a couple of people who were in workshops with us on a different thing this summer actually know that, because we did a very little talking. We actually did mostly work in the classroom. So it's one of those things that you've heard far more talking than you would have ever heard in a workshop. So yes, we actually put them through a lot of that as well.
And there is a template for the teachers that we use, as Deborah said, for the workshop, where they're giving kind of like an overview, and then they literally fill in each of those tasks and all the information that was on the left side of that sample I showed you.